So now let us reconsider a question we had in 2.1. It was number 1, I think. And that was, find the slope of the tangent line to f of x equals x squared plus 1 at x equals 1. Now, this type of problem can be phrased in a few different ways, right, that known right now. So finding the slope of the tangent line is now equivalent to a few other statements, and that is find the derivative. Find the derivative of f of x at x equals a. Right? Find the slope of the curve f of x at x equals a. Find the instantaneous rate of change of f of x at x equals a. Okay. All these employ the same methodology. All of them are asking the same thing in a slightly different way, conceptually. But they all mean the same basic thing. Right? And now, instead of using approximating and guessing, we can employ the definition. Derivatives to all these problems. And that's what we'll do now in this recapitulation of 2.1, number 1. And it should go faster than what it did when we were approximating and guessing, because there's less calculation. Again, because it's now analytic and exact instead of approximate, even if you have a good guess at the end. So we'll need to find f prime at 1. Right? F prime at 1 is the limit as h approaches 0 of f of 1 plus h minus f of 1 over h. And that should be, if f is really x squared plus 1, then this reads with the function rule employed here, 1 plus h in for x squared, so 1 plus h quantity squared plus 1. Right? That's f of 1 plus h. Minus f of 1 will be 1 squared plus 1. Yeah. All over h. All right, continuing. So if we square this binomial, 1 plus h squared is certainly going to be 1 plus 2h plus h squared. I still have another plus 1 in there. But the parentheses aren't really doing anything now. And we have minus 2. Okay. All right, so I have 2 minus 2 is gone. So now we have limit h approaches 0 of 2h plus h squared over h. I can factor off h. We have a limit as h approaches 0. A little sloppy there. As h approaches 0 of h times 2 plus h over h, h's cancel. So now we have a limit of 2 plus h. Screw this up just a little bit. As h approaches 0, for sure, as h goes to 0, we have nothing but 2 sitting here. And that was the answer we had before.